Good morning, dear students. This is Kantesh, and this time I will be handling a subject called Signals and Systems. And the course code of this subject is 18EE54. And the very first chapter is about the introduction of signals and systems, or introduction to signals and systems. And a textbook they have given, that is Signals and Systems by Simon Hackin, Barry Van Veen Willey, and second edition 2002. And four reference books are there. So all these books are available in our library, and also you can refer local author called Uday Kumar. That is also a very good book. You can refer for problems. So we'll move on to the next slide. That is the model number 1. Totally 5 models are there in signals and systems, and in that the very first model is about the introduction of signals and systems. So this introduction consists of signals and system definitions. So what is signal, what is system, how you are going to define, how to define those signals and systems with respect to real-time examples. Next is classification of signals. These signals are classified into 5 types. And the next is a basic operation on signals. So different operations are there, then those operations will be operated on this classified signals. That will be explained in basic operation on signals. Next is elementary signals viewed as an interconnection of operations. So some signals are interconnected, and there we are expecting an output operation or output. That is an interconnection operation. Properties of systems. Some different properties are there which are related with these basic signals. So those are stability, causality, invertibility, dynamicity. These are some of the properties which are there in the very first chapter. So moving on to the next slide. So what are the applications of signals and systems? So these are some of the examples of this. These are some of the applications of signals and systems in communication systems. So some signals will be there. Those are nothing but informative signals. So these are the example for informative signals, that is circuit design, biomedical engineering, power systems, and speech processing. These are the wide variety of areas where you come across the concepts of signals and systems. The next slide. So what exactly the signal is? In a simple definition, it is a function that conveys an information. Apart from these 3 definitions, I'll define like it is a function that conveys an information. That means it gives an information to the other blocks. That is your signals. For example, heartbeat. A human heartbeat is the best example. By keeping a stethoscope on the left side of your chest, we can get some signals, some heartbeat signals, some heartbeat impulses. Those impulses are nothing but signals. So depending upon that, the doctor will going to decide whether the patient health is good or not. If it crosses more than 80 bpm, that is beats per minute, that means the patient health is not good. If it lies within 80 bpm, that is beats per minute, then we can decide the patient health is at the margin level. That is how you are going to decide patient health depending upon the signal. So one more example is weather forecast. So we get quantities regarding the variation in temperature, humidity, and speed of a wind or a wind speed, etc. The signals represented by these quantities help us to decide whether to go out for walk or decide any activities. And so the definition, that is, these are a simple definition: a set of information or data, function of one or more independent variables, and contains information about the behavior or nature of some phenomenon. So apart from this, you can define signal in a simple way, that is, it is a function which conveys an information. So it is a function which conveys an information. That is the good definition for signal. And these are the best examples for signals. One is the distorted waveform and the other one is a share market waveform. So this is a distorted waveform. This gives an information. This distorted waveform gives an information that is everything is not correct. That means some harmonics are there in the loop. That is an information. And this is a share market waveform. You can look at this: 10 a.m., 12 p.m., 2 p.m. and 4 p.m. That means it is giving an information. These are the signals. It is giving an information. So next, what is a system? So by the definition, a system is an entity that processes a set of signals to yield another set of signals. That is what the system is. That means, in a simple way, the set of blocks which are interconnected, that we call it as a system. For example, if we consider our college consists of 5 plus streams are there: electrical, mechanical, civil, like this. Different branches are there. When you are going to connect these branches, when you are going to connect all branches, so that will become a system. In a simple way, it is an interconnection of blocks. It means a system is an interacting group of physical objects or physical conditions that are called as system components. Like a physical system is an interconnection of components, devices or subsystems. You can also represent it by inputs and output, by giving an input and output to the block. You can see this. A system may be made up of physical components as an electrical or mechanical systems. A system may be an algorithm that computes an output from an input or signals or signals. Software realization. The simple definition of system is it is an interconnection of blocks, nothing else. It is set of interconnection of blocks which consist of input and output. Input you consider x of n or x of t. Output you consider y of n or y of t. These are the examples. So the very first one is related with the current and voltage. X1 and X2 they will consider as voltage and current respectively as a function of time in electrical circuit. This is electrical signal, and this is generalized signal. A system, a block, this is a single block, and X indicates an input and Y indicates an output. That means a system consists of interconnection of blocks and input and output. Here also you can look at this. This is a system which consists of voltage source, resistor and a capacitor. With that, current is also flowing. This is what the system is. Next is signals are classified into 5 types. One is continuous time signal, discrete time signal. The very first one is continuous time signal and discrete time signal. The next is even and odd signal. Next is periodic and non-periodic signals. Next is dynamic and random signals. These are the different types of signals which we are going to study in the next class. So first I will in this class only I am going to discuss a basics of that continuous and discrete time signals. Continuous time and discrete time signals. So for continuous time signal, these two are the best examples, and for discrete time signal, this is the best examples. So what is that continuous time signal? So for continuous time signal, if you consider continuous time signal, you can define signal at any instant of time. The x-axis is the time scale, this x-axis is time scale, and the y-axis is the magnitude scale. So you can, that means you consider this sinusoidal signal. So you can define this signal at any instant of time. That is what continuous time signal is. That means you can define at any instant of time. That means at this point also you can define, at this point also you can define, at this point also you can define, at -1, -2, -3, at all the time instants you can define. That is continuous time signal. Or else you can also define at 1, 2 and 3. The right side of the S plane also you can define at any instant, 1, 2, 3 or 1.5, 1, 2.5 and 3.5. At all the time amplitude is varying. So this is what the continuous time signal is. Next is about the discrete time signals. So in discrete time signals, you cannot define the signal at particular instants. That means you can look at this sample. At 1 there is a signal, at 2 there is a signal, at 3 there is a signal, and in the left half of S plane at -1 there is a signal, at -2 there is a signal, at -3 also there is a signals. In this case you cannot define signal in between 1 and 2. Look at this, in between 1 and 2 you cannot define, in between 2 and 3 also you cannot define. So in between -1 and -2 also you cannot define, in between -2 and -3 also you cannot define. That is what the discrete time signal is. So once again I will repeat, continuous time signal, you can define the signal at all the instants of time. At all the instants of time you can define the signal. But in case of discrete time signal, it is not possible. Only you can define at particular instants of time. That is what the discrete time signal is. So this is about some of the basics of signals and systems. In the next class we are going to discuss the different components of discrete time signals, and also other properties or other classifications of continuous and discrete time signals. Thank you.